Okay, so guys, today we are gonna start with the chemical reactions of organic compounds. Family number one, which is alkanes. So we are gonna start with chemical reactions of alkanes. Chemical reactions of alkanes include combustion reactions, and the second one is substitution reaction of alkanes with halogens. Halogens group 7 elements: fluorine, chlorine, bromine, iodine, and hydrogen. Note: alkanes always undergo substitution reactions. Substitution reactions mean that they are not single shot reactions. In fact, these are stage by stage reactions, and the number of stages involved in this reaction will be equal to the number of carbon hydrogen bonds. For example, what it says here, that substitution is a step by step reaction, and the number of steps involved in a substitution reaction are equal to the number of carbon hydrogen bonds. For example, like we take the reaction between methane and chlorine gas. So here in stage 1 here, in stage 1 we react methane, which is CH4, with chlorine gas, Cl2, in the presence of UV rays. This is the condition. This you need to memorize. This is the condition. So when we react methane with chlorine gas, it forms hydrogen chloride gas and CH3Cl. How? That since chlorine is more electronegative than hydrogen, so chlorine can displace hydrogen from this CH bond. So the CH bond from here, this CH bond, it breaks, and chlorine replaces hydrogen from here. So hydrogen from here is comes here, and when this bond is broken, hydrogen attaches with Cl, forming HCl, this bond, and the Cl from here goes here and attaches with this CH3, so it forms CH3Cl. So this is the formation mechanism, and you don't have to write this entire step in exam. In exam you just have to write this in molecular formula like this, and you don't have to show these arrows. In exam style, just write CH4 plus Cl2. This is Cl2, and you must write UV rays above the arrow. So this is the condition, this is necessary. So in its presence, HCl and CH3Cl gas are formed. Now that was stage 1, and now in stage 2. In stage 1, what we formed was CH3Cl. Now in stage 2, we are gonna react with this CH3Cl with chlorine gas. As we have the chlorine gas, we will take the chlorine gas in excess amount. So we are gonna react with this CH3Cl with chlorine gas. So here the same mechanism is being followed, as the bond between CH breaks, and the bond between Cl and Cl also breaks, and Cl replaces hydrogen and bonds with CH2Cl over here. So CH2Cl2 is formed, and this H comes here, and again HCl is formed, and this also happens, and HCl is also formed, and this CH3Cl formed in stage 1, we call it this is chloromethane. This is its name. How? Mono means single, one chloro means one chloro, and which is attached with methane, so monochloromethane. And here CH2Cl is formed, so di here means 2, and 2 chloro, one here, and methane attached with methane, so we say dichloromethane is formed along with HCl. Exam style, you can see CH3Cl gas plus Cl2 gas in the presence of UV rays forms HCl gas plus CH2Cl2 gas. And stage 3 now. In stage 3, as I told you before, that this is a substitution reaction, so it will follow a step by step reaction. It will have many steps, and the number of steps depends on the number of carbon hydrogen bonds. So in the starting we took CH4 methane gas, So we have four CH bonds, so we will have 4 stages. So we are done with 2 stages, and now in stage 3 we are gonna react this stage 2 product dichloromethane with Cl2, as Cl2 is in excess in the presence of UV rays, again HCl, and in this case it forms it replaces Cl replaces another hydrogen, so 3Cl attached with C and H, so CHCl3 is formed, which we call trichloromethane. And this trichloromethane, tri here means 3, so chloro and methane, so 3 chloro attached with methane, so we name it trichloromethane. It is a note here which says it is also known as chloroform. It is also known as chloroform, which is used as anesthesia during surgical operations. Okay, this is an extra information. Memorize it, and in exam style you have to write it like this. Now stage 4, coming to stage 4, we react. So here in stage 4 we are gonna react CHCl3 plus Cl2 in the presence of UV rays, and HCl again is formed, and here the Cl replaces the last hydrogen, so all Cl are now attached with 4 Cls are now attached with carbon, so it forms tetra. Tetra means 4 chloro attached with methane, so its name is tetrachloromethane. In exam style write it like this. Okay, now here how to prepare alkanes and alkenes in the lab or industries. As we are done with alkanes and alkenes, so now we are on the topic alkanes and alkenes. So now we are gonna study how they are prepared in the lab or industries. In labs or industries, which is alkanes are prepared in the lab or industry by cracking of long chain alkanes. Both alkanes No, only alkanes are prepared in the lab or industry by cracking of long chain alkanes. Like we have larger alkanes, and we are gonna supply it with 300 to 800 degrees Celsius temperature and the presence of SiO2 or Al2O3, which acts as catalyst. These acts as catalysts. So when we are gonna proceed with this reaction, the larger alkane will break down into smaller alkane plus alkene over here. So this is the production method for both alkane, smaller alkane, and alkene from a larger alkane in the presence of these conditions. Memorize these conditions. So now for example here we have fill in the blanks. So C10H22 we have, this is I think decane, and we are gonna supply it with these conditions, the same conditions, and here one product is given, this is ethene. So alkene is formed. Now we are gonna form a smaller alkane. Here smaller alkane will come, smaller alkane. So what will be this, as we have over here C10 and C2 is formed, so to complete the carbon number on both sides of the reaction must be balanced. So here A10, we must also have here 10, so we are gonna write here C8, and then H, here are 22 and here are 4, so 22 minus 4 is 18, C8 H18. So what we have here, octane as a smaller alkane formed. Okay, now next reaction, C12H26. What will be here, this is a smaller alkane, this is a smaller alkane, so here we will have alkene formed. A smaller alkane is already formed. What will be the alkene now? 12 minus 9, C3H, 26 minus 20, C3H6. What is this? This is propene. Propene is formed over here. Okay, now here it is asking for the reactant, so here we are gonna just add these carbon atoms, C10, C14, which this is the larger alkane. He's asking us for the larger alkane, as he has given us with this smaller alkane, which is decane, and this alkene, which is butene. So C14 and H22 plus 8, 30. C14H30 is formed over here. Okay, you don't need to memorize their names, which are of carbon atoms with more than including more than 10 carbons. Okay, now as we have studied the cracking process chemical reaction equation, balanced equation, now we are gonna discuss the diagram of cracking process, how it takes place. So here actually there is a tube and a pipe is inserted in the tube, which is going through a beaker, and again into the tube a beaker is installed over here. So here in this tube we put this cotton wool soaked in liquid alkane over here, and here the catalyst, where the conditions, I wrote these are the conditions. So soaked in liquid alkane, this is the larger alkane which we have to break down into smaller alkane and alkene. So here we soak this cotton wool in larger alkane, and we react it with these catalysts, and when it reacts it goes through this tube and into the beaker filled with water. And then why we actually use water, here into the water, and then it is inserted into the tube into a beaker installed over here. So gaseous alkane is collected over water, as gaseous alkane is collected over water. As the smaller alkane, it is a smaller alkane, so it will be in the present in the form of a gaseous state. So when it will be formed after its reaction with this SiO2 or Al2O3, when a smaller alkane is formed, since it's in gaseous state and this alkene is also in gaseous state, so they will not dissolve in water. That is why we pass through water. They will not dissolve with water, and in fact they will go up in this vacuum, in this empty free space. They will be collected over here over water. Okay, this method tells us that gaseous alkanes are insoluble in water. Yeah, the examiner can ask this question, that why we use this method, what is the significance of using water in this method. So we are gonna write this as the answer, that gaseous alkanes are insoluble in water, so they are collected over the water in an empty space. This is the reason. And draw this diagram by yourself and memorize it. Okay, this much for this video, and next video we are gonna start with the reaction of alkenes, as we are done with the reaction of alkanes till here. Now in the next video we are gonna start with reactions of alkanes. So till then, goodbye, and don't forget to subscribe my channel and press the bell icon and give a thumbs up for this video.